give Cosmos Automation a warm round of applause. So introduce yourself, let us know what you do, how you got into technology, and then 10 minutes for the presentation.
Good afternoon, everybody. My name is Abaraji Promise. I'm the CTO of Cosmos Automation, and that's my friend.
Augustine Waffle.
Yeah, he's
colleague.
Yeah. So Cosmos Automation is our dream to bring technology in Nigeria here. We are into automation. Our first product is called Nyamere, and an IoT irrigation system. Yes, we used it in Enugu State competition, hackathon competition last week. So, and we had another product that is being produced. We want to make Nigerians to use inverter. So we made it cheaper for them. So we built a small inverter box that we want to be selling at the rate of 50,000 naira for every Nigerian. So that's our second product. So now, how we got into technology, we graduated from University of Nigeria, Nsukka. So we are classmates and we love technology. I want to take it to an extent that we want to start producing here in Nigeria. So we are enthusiasts and want to take it professional. So here is our meter. When you talk about meter, you talk about standards. When I saw the competition, I asked myself, when I saw the list, the things they listed about meter and the standards in meter, as engineers, I asked myself, what are the standard multimeter? What's the meter I will build here that can be used in America? What's the meter I'll build here that will be used in South Africa? The meter I'll build here that will be used in every other part of the world. So in meter standards, the language and metering system, which is called DLMS. So this DLMS COSM is the language in meters, energy meters. So we sat down, though we saw this late, 2 weeks, but we sat down with our friends online to sit down. We worked more on the programming of this system to work on DLMS objects, the interfacing. We just did the first and the second level. And we now talked about the IoT part of the job. The IoT part of the job is when we use MQTT, so that every other person that is using, every other system that is working on IoT can be able to easily connect to it. MQTT is the most standard way of running IoT. That is machine telemetry query transport. So that's what is being used. Then, under the DLMS, we divided it into two. We have the one that works, there is a server system that have two means of access. Our access is of two. We have the non-authentication and the high authentication. The authentication is when you want to access it through these optical ports. That is when you have to use password. But when the one we are running through our MQTT dashboard, our MQTT system, we are running it on non-authentication. So where in the non-authentication system, MQTT is very secured. You use key on it. So we don't need to put authentication on the system again to weigh down our speed, our processing speed. So we just left the second access on non-authentication so that our MQTT system our IoT system can easily access it. Okay. So now, based on this meter, we launched it on an MQTT cloud. We are not the owners, it's owned by Adafruit. We launched it there to test it, to know if our system met an MQTT standard. And as we are talking now, it's working on Adafruit and Adafruit's MQTT IO. And that means that it met the standard of MQTT and it can work as a server system. We used somebody's DLMS access system to test it. This guy, he's from India, so he gave us a software on DLMS, on his DLMS client systems. So we used it to test the system if it can access DLMS via Syria, which is RxTX. So, and we found out that our system can actually authenticate in these two ways. We have high and the non-authentication systems. So apart from that, energy meter, normally, as we know it, has one thing in common: monitoring of energy. So when we now, apart from the standards, the monitoring of energy system now have to deal with your current reading, your voltage reading. So we used current transformers of the ratio 2500 by 1. So, and we use an ADC, ADS 115, which is a 16-bit ADC to measure our current and voltage. So separating it from the ADS of our chip, the chip we use, actually we sourced a chip. We have used a chip, a Texas Instrument chip. But when we saw this, it was for it to come from outside the country to this place, I think the competition would have ended. So we decided to use a chip in the market that we saw that at least, because we wanted to use ESP32, but it was unstable with the system to work with our ROF. You know, we have ROF system here for our CTS. And so our ESP can't work with the ROF, so because the SPI has issues. So we now decided to use an ARM chip, which is Atmega 2560. So that's what we used. So, and this chip, in this system, we had battery inside. So why we built this system this way is that people can't tamper on it. Like when we brought it here, see, it was beeping to show that it's online, constantly online. So that nobody will say, okay, there's no light, let me go and do something, let me go and do a magic. So once there is no light, the system is on 24 hours and it updates on our server every 1 hour. So if you do any tamper, immediately we'll see it here on the dashboard. And if you make payment, we will see it here from the payment. Now, I think we have two tamper systems. We have tamper here and tamper at the terminals. So you will remove the terminal now so that you've heard it, just on removing it. You see now our dashboard is now red and the system is off. Let me bring out my light bulb. So, yeah. So that's the light bulb for us to see it. So once you tamper, anywhere you are, once there's light or no light, our system has 4096 addressable EEPROM. So it can save, and each address saves 100,000 times. So these are about up to more than 15 years memory usage. So if you not say that maybe there's no light, you want to tamper, you should try it. So when you try it, immediately our system will notice it. And now this guy has been cut off. So before you tell us to put him back, you have to explain to us what he's doing on the meter. Because even on loading the CTS token or anything, you don't go to the meter. We have a separate CTS token loader that is here working with ROF that you can easily put your token here and the meter will immediately receive it. And on this CTS token, this system is sending the date, time, and units that is remaining instantaneously. So you will not tell us that, okay, I went to there to see my date and time. And this is logging to MQTT. And anybody that is running any software system or software platform can easily take any variable from this our MQTT dash and put it in their software. If you want to run admin, you can run admin. But what we have here is we want to run the standard that anybody that wants to use anything you want to use, you can easily use it. So before I continue more to talk about this, I'd like my colleague to talk about the bypass systems. Thank you.
Okay, so for the bypass, we notice that people usually bypass their meters in different ways. The first one is by cutting the wire and connecting it to the earth. Now, what we did was that we used two current transformers, one on the live and one on the neutral. So even if you bypass, we'll detect it from here because there will be current disparity. Then people also bypass by putting magnets to block the current transformer from measuring accurately. So for that one, we made a provision to put a magnetic shield over it, but we couldn't get that on time. But we made a provision to put a magnetic shield. But then in final product design, there'll be a magnetic shield over it that will make sure that even if you place the magnet on top, you won't be able to bypass.
Information, you have about 2 minutes, so I believe you
Okay.
can just round things up so we can
All right.
take questions.
People also bypass by reversing polarity. Now, our current transformers can measure reverse current. Other than that, we also use the absolute value. So even if you reverse polarity, we use the absolute value and then we'll measure your units correctly. Then for the bigger system, because each meter has a meter number, and the meter number will be tagged with the location. Now, if we are supplying this location and they all have their meters and they're all logging if they're powered on or they're powered off, so they're all logging the power state. Now, if your meter hasn't logged for a while and all these other meters in the same area has been logging that they've been bringing and taking the light, then we know that something is wrong somewhere. So that's also another way we can detect that bypass. Then we'll also make payments.
Okay,
Okay, now if you look at this, the LCD is turned off. That's because we're in battery saver mode. But it enters battery saver mode when there's no load connected, you are cut off. That's maybe you tampered or you bypassed, you are cut off, or there's no light. So if there's no light, or there's no load connected, or you bypass, they are cut off for any reason, it enters the battery saver mode, so it saves battery. So now it is red here because it has detected breach. So we'll first reset it from here.
So as the red, so you can reset it from here. So once we reset it from here, okay. That is. We'll press the reset. This is the Adafruit MQTT dash. Is it not showing? Okay, that's the Adafruit MQTT dash. So you have seen this is the breach. That time we removed it, it showed breach, and this is the power status that showed that the power status is off, and this is the power state. So once we reset, so this is a GPRS to take a little while.
We'll give an opportunity for our judges to start asking questions, and perhaps the GPRS will actually cooperate. But a warm round of applause for Cosmos Automation. Well done, well done. Thank you very much. So we'll open the floor for questions.
Cosmos, I think I would like to try and almost be the defender of the other people that came before you. So you have a benefit. That is that I call it the benefit of the last presenter. You got a good sense, and it's not a bad thing, it's a good thing. It means that you listened a lot and you got a good sense of going straight to the issues that are the hearts of the judges and everybody else. And a good job by doing that. However, there's also something important about price. I was very curious for you to get to the point where you can talk about the cost of production of what you did. And make it interactive. You don't have to wait till I finish. You can yell out the number. Whether it was 15,000, 25,000, you can state it. Just say it. So price being an issue. And then apart from that, I also don't want to take away from the whole local raw content of your presentation. It comes off a bit like you're the front room of a like a Mojek or MoMA's doing already gone very far. We don't need you to present something that is let me speak for myself. I want to see, I'm enjoying that UNN, that completed part of your stuff. Don't tell me about the other. I meet a lot of meter manufacturers every time, but I want you to just show me your production. So let's hear about just your view on that and your cost of production.
Okay, this meter, everything we have here is sourced outside, the chips and everything. So our cost of production here is up to 12,000 naira. Cost of production because they are sourced outside. But when we now go into major production, this is just producing a prototype which is more costly than going for major production. We sourced on the major production. We saw that each of these meter can cost like 8,000 with the CTS. Yes. Is that a UI? Yeah, this is the token loader. Yes. And you can view it here that if it sends the time, you can view it here. That's the units in the meter. You can see it. It receives real time from this guy, and we have tokens here that we just generated from ourselves using parity bit and other things. That if we enter the token, the meter will receive it. Like let's just run that one as an example for you guys so that you can see it. And can Austin?
Yeah.
Let's just come hold this. Let me.
This one here.
Okay. So this is 1, 2, 9, 1, 4, 7, 2, 8, 6, 9, 6, 3, 5, 4, 2, 4, 4, 1, 0. Okay, 0, 9. Yeah. See, processing valid token. Recharge successfully. So this is 9.0. So now when we type this system now to show that it have received the token. Have you seen that? From this. Okay. So
it's having some issues, but once it comes online, it will immediately show here that I received
the token.
That's
why we produce.
And if you try to load that same token again, try it again.
Okay, if we try to load this token again that we have done before, to tell you that this token have been used before. So this also has memory that it saves that you've used this token before, and is able to tell you that you've used it before.
So
honestly, I part of the question was asked earlier, but I just wanted to commend you guys, Cosmos. I think this is probably the most detailed I've seen in all the presentations, taking into account core, items that manufacturers would actually be looking at, right? As well as probably the most close to going to market, right? So I must really commend you, and very well thought out as well. I would just want to ask you whether your design, because I noticed you have IoT, which is the MQTT, you have a UIU. So can you use the design without a UIU also? In other words, your dashboard, could you create one for the user without having to use a UIU, right? So in terms of when we're looking at cost considerations, right, these are some of the things that we will all be looking at, right? Eliminating just the use of the UIU. But if I could put some money, behind this, I will be putting. Okay, am I allowed to say this? Yes, you are. I will be putting my money behind Cosmos automation and Engineer Balungu. I don't know if you want to start a bidding war, but I would be starting at $50,000.
Thank you, Chantel. Cosmos, you are, at least from my criteria of evaluation, you are the best for now in my own assessment, because you really go into the entire simulation of what meter-based inputs and outputs are. You have two, this is a single phase. You have two live and neutral in, live and neutral out. And you equally have UIU. You said you use RF for communication, and you are so sensitive about standard from your presentation. The first thing you mentioned is standard, and that's what you need to do. Cosine DLMS is hidden unit of a network interoperability for meter to be able to talk to one another. But on the downside of it, there are some other standards that you're supposed to have considered. I will have carry on a query on your meter now, the DLMS query on it, if it's going to pass. Otherwise, if it pass the query, if you are sure that if I send, come there and send you the query command and it will pass, then you win the best of prize. If you are sure of that, but if you are not sure, let's leave it at that level. However, you are the best in terms of understanding what the industry requires. What you now need to do to further your knowledge and your design techniques is to study all the various book of standard. Try to join IEC to study all their white, blue, and white book, all the 3 books. You understand it so that you'll be able to comply to it. Then study metering code for NEC. Inside the NEC website, you will see metering code standard. Then there is communication protocol standard too. You conceptualize all those things so that you can improve. Like what Chantel has said, if I want to put my money on anybody, it's on you that I'm going to put my money on. When you have tried so much, and we will do further evaluation because we need to be able to test how you design your board. Do you design your board yourself? Do you send the board for PCB design? So if you don't design your board, then you need to know more about embedded design so that you'll be able to design your PCB board at any point in time. So we can make the PCB for you at any point in time if you can design. Well done very much. Thank you.
Thank you very much.
Do we have any more questions? I know we're fast spent for time, but at this point, I'm sure I can squeeze in an additional question, or maybe perhaps online. Okay, I can't see.
So I'll just congratulate the team for good work. Very professionally presented and technically, I think, sound as well. You did talk about your inputs being mainly imported at this stage.
Yeah.
But you said when you go into production, you're able to reduce your cost.
Yeah.
How much of that do you reckon you could produce locally?
Okay, based on this, from what the questions that we are asked, this system is a dual system. It takes in, payments from here, and via our MQTT systems, you can also receive payments from there. MQTT is a standard protocol that anybody that is building any UI, anybody that's building any site, once you incorporate it, all you just need is our key, the key for the meter. Once you get the key for the meter, you can send any information to it encrypted via MQTT. So based on our circuit, we built our circuit house. In fact, we used, because of the time we spent on the code, we have to use a Vero board to solder ourselves raw. You can see it, you can see the battery inside, the charging circuits inside, nothing went to China. Okay, so based on the cost of this, you can, this chip we used is a module. The cost for per chip should be like 1,000 naira. But because this chip is on its own, is not in Nigeria, so we have to buy it in a module. So the cost of the module itself is 7,000 naira. You can see the cost difference. So that is what made this to rise. Most of this mount. So the chip itself should be like 500, but because of the chip is not here, you can only buy it in a module. So we bought the module. This module, we have to remove some things from the module for us to use it to work. So this module is sold 1,800 naira. So these are the costs that we are having because these things are not here. You buy them in a module and not in chip. Even the GSM module we use here is also in a module. You can't get SIM 900 or SIM 800, or even the 3G. Even a 3G is sold 35,000 in a module. 35,000 naira. So you are seeing the costs, all these things that are coming up that when you want to do some of these prototypes, we don't have it here. We just buy the modules and put them together and you have it work. So that is it. But if we are to do more normal manufacturing, yeah, we can just get the chips, design the circuit. We do our design on Ego. So Ego and Easy EDA. So we can just design them and mass produce them. And it will be way cheaper. Thank you.
Thank you very much. A warm round of applause for Cosmos Automation.